So synthetic routes, how different types of compounds can be formed by using different reaction pathways. As we have discussed different types of compound, like we have discussed starting with alkane, then alkene, then we have the alcohols, carboxylic acid, aldehydes, ketones. So this is a very important reaction pathway. This is a flow chart. You can start with any of them. I'll share after the session, I'll share this. So because it's like how you relate the things. Because in organic chemistry, things are interrelated. Let's say you are starting with alkene, or you can also start with alkane. It's up to you, any one of them. So what if we have alkene? If we start with alkene, so if we react with either halogen like bromine, chlorine at room temperature, the reaction will be electrophilic and the mechanism will be electrophilic and the type will be addition. And as a result, it will produce dihalogenoalkane. Like dihalogenoalkane means two halogen atoms are attached to a carbon chain. But if you have alkene and you do oxidation, so what it will result in a formation of diol. Or if you have a dihalogenoalkane and you use potassium hydroxide, aqueous potassium hydroxide, heat under reflux, then you will have a nucleophilic substitution reaction, which is also known as the SN reaction. This will also form a diol. Or you have an alkene and you react with a hydrogen, it will be in the presence of nickel as a catalyst, so addition reaction will occur. And we can also say reduction because it's an addition of hydrogen. So that result in a formation of, yes, you have to learn this entire, uh, because this is a reaction pathway. Like different chemical substances can be produced by different, at different conditions, the synthesis routes. So if you have an alkene and you react with hydrogen and nickel as a catalyst, so this will result in a formation of alkane. If you have alkene and you react with a hydrogen bromide or hydrogen chloride, this will result in a formation of halogenoalkane at room temperature and electrophilic addition. I wrote mention here the mechanisms as well, like what kind of reaction will happen. If you have alkane and you react with a halogen like bromine and chlorine, then it's a free radical substitution reaction. This will also result in a formation of halogenoalkane. If you have a halogenoalkane and you react with potassium hydroxide in alcoholic medium, then the elimination reaction will occur and it will result in a formation of alkene. And these alkenes, you can do polymerization and it will form a polymer of these. This will result in a formation of addition polymer. If you have a halogenoalkane and you react potassium hydroxide, aqueous potassium hydroxide, this will turn into alcohol. But if you have alcohol, you react with PCl5 or PBr3 or PI3, this will again form a halogenoalkane. And if you have halogenoalkane, if you react with ammonia, it will form amine. And then amine can have multiple substitution depending on what you have more. If you have like a limited amount of ammonia, then it will result in a multiple substitution. If you have amine and you react with acyl chloride, it will form a secondary amide. Amide you don't have to learn right now. Like the detail of amide, this part you don't have to specifically learn. And if you have an alcohol and you have a primary alcohol, it will oxidize to form aldehyde. If it's a secondary alcohol, it will form a ketone. If you use lithium tetrahydrodealuminate in dry ether, it will reduction reaction will take place. It will produce alcohol. And if you have a ketone, a reduction reaction will result in a formation of ketone as well. Ketone reduction reaction form an alcohol, a secondary alcohol. Same way, if you have an aldehyde or a ketone and you react with HCN and potassium cyanide, a nucleophilic addition reaction, which will produce a hydroxynitrile group. But if you have aldehyde and you further oxidize, it will produce a carboxylic acid, and the carboxylic acid can be reduced back to alcohol by using a reducing agent. And if you have a nitrile group, if you do hydrolysis of the nitrile group, it will form a carboxylic acid. And a carboxylic acid, you combine with an alcohol, the carboxylic acid plus alcohol will result in a formation of ester. And then the acyl chloride, this part not specific right now because you are not learning acyl chloride or amides. Only this part you don't have to learn. Rest all of this reaction pathways you have to learn. Like you have to memorize how the one reagent can be converted into another. So for example, if I say we have alkene, okay, and I want to produce amine, what you will do? Alkyl to amine. So you have to recall it. It's only like the reaction pathway. So first, alkene, what I will do, I will react alkene with hydrogen bromide or hydrogen chloride. This will produce halogenalkane. And this halogenalkane, I will react with ammonia to form amine. Same thing, if I say I have alkane and I want to produce alcohol. So what I should do? First, alkane reacted with halogen, like free radical substitution reaction, produce halogenalkane. And this halogenalkane reacted with potassium hydroxide aqueous to produce an alcohol. Same way, if I say I have alkene and I want to produce ketone. So what is the reaction pathway? Different pathways are there as you can see. So I can first produce alkane, then I can produce halogenalkane, then I can produce an alcohol, and then from alcohol I will get a ketone. If I want to produce a carboxylic acid from alkane, so I will convert into halogenalkane, then halogenalkane I will convert into alcohol, and alcohol I can convert into aldehyde, and then the aldehyde I can convert into carboxylic acid. So they are actually linked with each other. It's the organic chemistry, the reactions are, these are a very basic type of reaction, and you have to learn the reaction condition and the mechanism how it proceed. Is it clear? The synthetic routes for the reactions? Anyone having a doubt or question this?